What if the universe is not physically falling apart, but our understanding of it is? For more than a century, scientists have constructed a detailed story of cosmic history: the Big Bang, the formation of the first particles, the first atoms, the first stars, the first galaxies, and then, over billions of years, the vast cosmic architecture we observe today. It was an elegant and powerful timeline, supported by generations of observations and refined through decades of scientific discovery. Then the James Webb Space Telescope opened its golden eye, and almost immediately the universe began to look different. Not just slightly different, dangerously different. Webb peered into the deepest regions of space, where light has traveled for more than 13 billion years before reaching us. There, it found galaxies that appeared too massive, too mature, and too highly developed to exist so early in cosmic history. It discovered ancient structures where there should have been cosmic infancy. It found black holes that seemed to have formed far too soon. It uncovered objects so unexpected that scientists began referring to them as universe breakers. That nickname is more than dramatic. If these discoveries truly are what they appear to be, they may not destroy the universe itself, but they could overturn the version of the universe we thought we understood. Before we can appreciate what Webb has found, we first need to understand what astronomers mean by the edge of the universe. It is not a physical wall or boundary where space suddenly ends. Instead, it marks the limit of what we can observe from Earth, the observable universe. This is the portion of reality whose light has had enough time to reach us since the beginning of cosmic history. Beyond that limit, there may be countless more galaxies, stars, and cosmic structures, perhaps even an infinite continuation of space, but their light simply has not had enough time to arrive. The observable universe stretches about 93 billion light-years across. That number is almost impossible to comprehend. Light travels nearly 6 trillion miles in a single year. Yet even at that incredible speed, it still requires tens of billions of years to cross the immense distances we are discussing. When we look deep into space, we are not only looking across distance, we are looking backward through time. A galaxy located 13 billion light-years away is not seen as it exists today. We see it as it was when its light first began its journey toward us. That means the deepest images captured by Webb are not simply photographs of distant places. They are time machines, revealing the universe during its earliest chapters. And this is where the puzzle begins. According to our current understanding, the early universe was supposed to be young, chaotic, and still under construction. The first galaxies were expected to be small, irregular collections of gas and newly formed stars, gradually growing larger through collisions and mergers over billions of years. Instead, Webb looked into that ancient darkness and found something entirely different. It found giants. Among Webb's most surprising discoveries was a group of 6 massive galaxy candidates that appeared to exist only about 500 to 700 million years after the Big Bang. While that may sound like a long period of time, on the cosmic calendar it is almost the beginning. Considering that the universe is approximately 13.8 billion years old, finding enormous, mature galaxies so early is like discovering modern skyscrapers in a village founded only yesterday. Scientists expected to see young galaxies, small, messy, and still evolving. Instead, Webb detected objects that appeared bright, enormous, and remarkably well developed. Some seemed to contain the combined mass of billions of suns. One candidate was estimated to approach the size of the Milky Way itself, despite existing billions of years before our own galaxy had reached its current state. That is why these discoveries earned the nickname universe breakers. Not because they threatened to destroy stars or galaxies, but because they appeared to break the accepted timeline of cosmic evolution. If these early observations accurately reflect reality, then galaxies must have formed far more quickly than current models allow. Stars would have had to ignite, evolve, explode, recycle their material, and assemble into massive galactic structures in only a fraction of the time scientists believed possible. This raises one of the most profound questions in modern cosmology. Did the early universe evolve much faster than we have assumed? Or are we missing a fundamental piece of physics? Perhaps star formation was dramatically more efficient during the universe's first billion years. Perhaps dark matter allowed enormous structures to collapse much faster than current simulations predict. Or perhaps some of these mysterious objects are not ordinary galaxies at all, but rapidly growing supermassive black holes whose brilliant light makes them appear galaxy-like. Whatever the explanation may be, Webb has forced cosmology into unfamiliar territory. The data did not quietly suggest a small correction to existing theories. It challenged the entire narrative. Then the mystery grew even deeper. Webb did not only uncover mature galaxy candidates in the infant universe, it also revealed evidence of enormous black holes appearing astonishingly early in cosmic history. One of the most remarkable discoveries involved a supermassive black hole containing millions of times the mass of the Sun, located inside a galaxy that existed when the universe was only about 570 million years old. That presents a serious challenge to current models. Black holes are expected to grow gradually. They feed on surrounding gas, merge with other black holes, and slowly accumulate mass over immense periods of time. But growth requires time, and in the young universe, there simply should not have been enough of it for some of these objects to become so enormous if they began as ordinary stellar remnants. As a result, scientists are confronted with a profound possibility. Perhaps our understanding of how the first black holes formed is incomplete, or perhaps the early universe operated according to processes we have yet to fully discover.